Hi, I'm Manish. In this series, I will be walking through an end-to-end machine learning project, which will cover everything from data exploration to model deployment via web publication. My goal is to provide general insight into the different components involved in getting model to production. This series is not intended to be a comprehensive overview of the machine learning pipeline. This article will cover data exploration, model training, model validation, and model storage. Throughout the series, the reader will be exposed to various languages and technology such as Github, Python, SQL, Flask, HTML, CSS, and Heroku. Then, this is an objective. This project is used to predict whether the person have heart disease or not. It helps to create a complete study proposal. In my methodology, use training set as well as machine learning tools to train a classifier. I use different algorithms like Navy bias, classifiers, gain, and logistic regression, SGBoost classifier. The SGBoost classifier gives better accuracy compared to other algorithms. Why heart failure? Heart failure, very common and deadly disease. 5 to 10% of adults over 65 suffering from HF in developed countries. 35% risk of death during year after diagnosis. In my dataset, the dataset having the records of people who have heart disease. X will contain two all independent variables. Y will contain the dependent variable. The column name is death event. Output class 1 heart disease, 0 normal. Target equal to 1 implies that the person is suffering from heart disease. Target equal to 0 implies the person is not suffering. Implementation details. Um, I use logistic regression, stratified search state, confusion matrix, and accuracy score. This is my classifiers. Um, I use logistic regression, decision trees, SGBoost classifier, SGBRF classifier, random forest classifier, and K and neighbors classifier. This is my accuracy. I got logistic regression 90%, decision tree 93%, SGBRF classifier 93%, SGBoost classifier 96%, random forest classifier 96%, K neighbors classifier 63%. This is experimental results. This is SGBoost classifier scores, and also I will calculate random forest classifier score, decision tree score, logistic regression score. This is feature importance. In this figure, which column have a great score? It represents which columns have a great score. This is conclusion. Okay, this is my short code. We will start by examining the data that will be used to model hot failure probability. I won't go over every line of code, but all of it can be found in this notebook. To start, we will import all the necessary libraries and specify a few storage path that will be used to run. First we import pandas, numpy, matplotlib, cbound, flatly. Then we will read CSV5. Then basics head, describe, is null. Next we will read data from the dataset from my dataset. Then our dataset appears to be a nice mix of categorical and numeric features. There is not a whole lot of training data to work with. However, this will make model training time fast and allow us to easily performing hyperparameter tuning and cross validation. Our next objective to individually analyze the categorical and numeric features. All of the categorical features have really low coordinately. This will make it easy for the model to encode and process these features. One interesting property of this dataset is that roughly 79% of the patients being studied are male. Moreover, over 90% of patients with heart disease are male. Okay. Initial model training. The model of choice for this series and will beginning by training and evaluating a simple model instance. Below we create training and testing dataset. The training dataset consists of 80% of the original data and the testing set is 20%. In order to replicate the results of training, specify random state of 2 in the train test split function. Okay. Then okay, for logistic regression, we predict. Then we find accuracy score of logistic regression. Then we we find decision tree score, SGBR of classifier score, SGBoost classifier score, K neighbors classifier score, and SPM score. This is the classification report. We find logistic regression in classification report and decision tree classification report and SGBoost classification report and finally random forest classification report. Okay, this is the feature importance. Feature importance represent which column have a correct score. Okay, finally the okay, I got it. Okay, let's see my I will create 4 HTML pages before and form data index.html result.html. Okay, then finally my app. Wait a few minutes. Okay, this is my app. Click get your prediction button and you put creatinine phosphogenic value and serum creatinine value and then click submit button. You have a result, high chance of heart failure. Another prediction, put 25 and 1.3, then click submit button. You have another result, low chance of heart failure. Okay, thank you.